Welcome to Plutus Project-Based Learning 2024 from Gimbalabs and Friends. This video accompanies lesson 202.3, Minting Native Assets in an App. Before you start with this lesson, I really recommend that you complete Module 201, where you learned about Mesh SDK for the first time, and the previous lesson, 202.2, where you learned how to mint native assets with Cardano CLI. Now, I don't know if you have access to a Cardano node, and I'm not sure if you completed this lesson right here. But even just reading through how the transactions work will be really helpful as you jump in to this lesson. What we will do now is investigate how to mint native assets from a web-based app using the Mesh SDK that you first learned about in Module 201. There's a link right here, and you can explore the entire library. All of the example code is in the PPBL 2024 front-end repo, and we can see the examples live at plutuspbl.io. Let's take a look. From the home page of Plutus PBL, I can click on Live Examples, and then let's select the one for Module 202, and then connect to Wallet. Two demos will appear on the screen, and these are very similar. We're going to look at the source code in just a minute, but what you can see here is that demo number 1. Oh, we got to fix the spacing there, but I'm going to zoom in a little bit for you. In demo number 1, we're pulling the pub key hash from the wallet that's connected to the application. And as a result, when we use that pub key hash right here in the native script, we get a unique policy ID. Yours will be different from mine when you connect a wallet to this website right here, because each of us has a different pub key hash on the blockchain. So when you click this button, you'll mint a token with a policy ID that only you can mint. When we look at the example code, I'll show you how to change the name of the token, but the policy ID is being derived directly from my connected wallet. I can sign the transaction, and I can see that I have a successful transaction hash right here. It looks like it's confirmed. And so now in my wallet, I should be able to find a custom token with the policy ID that you can see in the web UI right here, B4F9333. You won't be able to mint a token with this policy ID. Yours will be unique to your wallet. In the second example, we're using what's called an app wallet, and we'll look at the source code for this as well, to have our application sign a transaction. We're doing this for demonstration purposes, and as you'll see in the source code, our demo is incredibly insecure. That's why we're calling this token an unsecured asset. What we've done here is we've added some private keys directly to our Git repo as an example of showing you what not to do. And at live coding, we can talk about ways to better handle this kind of logic. But just so you can see how it works, I can once again click the button, then sign the transaction, and once again wait for confirmation in my wallet. There it is, my unsecured PPBL 2024 token. Great. So both of these examples are available for you to play around with directly from plutuspbl.io. But hopefully you also want to know how these components were built. So let's take a look at the course repositories, and this time we're going to look at the PPBL 2024 front end. This is the same repo that you used in Module 201. I have it open on my computer, so let's go into VS Code and take a look around. In the source directory, there's a components directory, and you'll see transactions right here. Then inside of transactions, there are some simple ones that we've looked at earlier in the course. And the two that we were just playing with on the Module 202 examples are right here in Mint Native Assets. This one, Mint Native Asset with Connected PKH for pub key hash, this is the first example with the asset that only you can mint. Then there's a similar one right here. This is the second example where we're minting with an app wallet. As always, make sure that you've pulled the latest changes with git pull. Then run npm install just in case there are any packages you're missing. And finally, you can run npm run dev to start your development server. Now I can view the same project locally. Here's the PPBL website running on my computer. I can once again navigate to the live examples, choose Module 202, and connect my wallet. While I'm here, I'm just going to clean up the formatting a little bit. All right, that already looks better. At least we can read the entire native script. Let's first take a look at the first example, minting a native asset with connected pub key hash. And at the top of this file, in the comments, you'll see similar steps to what we completed in lesson 202.2, just like it's outlined right here in the lesson. In this example, instead of generating new keys, we're going to use the connected wallet and we're going to generate a public key hash from that wallet address by using the mesh function resolve payment key hash. Because the user's wallet is not always connected when they first view this component, we're going to add some hooks right here to give us a mesh browser wallet and use address, which gives us the address string of the connected wallet. We set up some use state hooks to hold the public key hash of the connected wallet, a native script derived from that, a forging script, and a policy ID. And here in this single use effect hook, we can see that every time the address changes, we want to set these values. Resolve the payment key hash of the address, and we set that as the connected pub key hash. When we have a pub key hash, we can use it in a native script object that should look pretty familiar if you completed the previous lesson. We use the mesh forge script class and the from native script method to take the native script and prepare it for minting. We use this forging script below, down here, when we want to mint an asset. And then just for our UI, we can calculate the hash of the native script. And that's actually all that a policy ID is. It's a particular hash of a native script file. So this hash is effectively our policy ID. And we don't need it when we're actually building the transaction, but it's nice to be able to show it in the UI. So that's why we set the policy ID here. And you can see that's what's being displayed in the UI. Once we've set these values, we're ready to build a transaction when the user clicks a button. And if there is an address, right, if there is a wallet connected, we can set some additional values right here, including the NFT style name of this token, an image to be associated with it. And this, of course, can be an IPFS address like it often is for NFTs, but you can also just use a hosted image like the Gimbalabs G. A description, and you can change this part. An asset name, you can change this part. The quantity, if you want to mint more than one, you can change that as well. And because you're running this project locally, I encourage you to play around with these values. Mint your own tokens, add a different image. We'll talk more about NFTs in the next module, but if you're minting a token right here, you're already partway there. Just to demonstrate this, what if I wanted to mint a Hello World token? And what if I wanted 12 of them? I could save that. And in my local UI, now when I attempt to mint this native asset, I can have the same policy ID with different asset names. But when I go to mint it, I'll see the quantity and the token name have changed. I'm not going to finish minting that right now. I get an error that says the user declined to sign the transaction. That's okay. Once we set these values, we create a new transaction instance. In this case, we can call it whatever we want. I'll call this one minting TX. And then we call the mint asset method on that, which takes a forging script and an asset, which is defined right here, to mint a token. And that's all. What's really cool about starting to use SDKs like Mesh is that after you've experienced this kind of transaction building with Cardano CLI, you might be recognizing right away how convenient this is. We don't need to select and input UTXO. There's a lot of boilerplate that we don't have to use in this case. Once we're using Mesh, we can simply mint the asset, we build the transaction, we sign it, and we submit it. It's pretty exciting. What I recommend you do is compare this code with the example you saw in lesson 202.2, and let us know if you have any questions. The last thing you'll see in this component is the UI part. We're styling this with Tailwind. And if you're not yet familiar with Tailwind, don't worry about it for now. If you want to learn more about web design, we can set up separate sessions for that. Hopefully, this component gives you enough that you can start to customize it or use it in a different project. And if you build something, make sure to let us know. We'd like to be able to celebrate your work. Let's move to the second example. In this example, we're creating what's called an app wallet to hold a set of keys that are unique to this application. We set up App Wallet right here. When we do, there's a few new things we have to cover. First of all, we're going to pull in some keys that were generated with Cardano CLI. And I mentioned that this is an insecure token. This string right here is a private key. And when I place it in this public repo, I'm doing the last thing you ever want to do with a real private key. In this case, I'm doing it just to demo for you what not to do, but I would never do this with a mainnet key, because if I do, someone else could use it on mainnet. Another thing that's new here is that we're pulling in what's called Maestro Provider. And we'll talk a little bit more about this when we cover queries in Module 204. In order for this to work, I need a Maestro API key, and I set that as an environment variable. If you want to run this example on your own, you'll have to get a Maestro API key and add it to your .env file. If you've never done that before, we'd be happy to help you at a live coding session, and we can create some bonus content for people who are just getting started building front-end applications. There are a couple of differences that I want you to notice about this example compared to the previous one. First of all, we're setting all of our variables outside of the actual component function. That's because we can know these values before the user loads the page. Remember, in the previous example, the pub key hash was coming from the user's connected wallet. So we couldn't know these values until a wallet was connected. But here we're setting up an app wallet. We're deriving an address for it and then using the address to calculate the pub key hash. We're dropping that pub key hash into a native script object, creating our forging script and our policy ID. And then we don't need any use effect in this component right here. We can simply use those values. This starts to be pretty efficient. Once again, we can set the asset metadata. You can play around with the name and the image, the description, the asset name, and the quantity. And we're sending, once again, to the connected address, right? Just the address of the connected wallet. The minting TX part is exactly the same as in the other example. The biggest thing that's changing is right here. Because in this case, we need 2 signatures. Compare this to what you saw in the previous lesson as well. First, we have the app wallet sign the transaction. In the previous example, we only needed to pass 1 parameter to the signTX function, just the unsigned transaction. But now we also have to mark true. What does that stand for? You see how it says partial sign, Boolean. We add true right here because this is only going to partially sign the transaction. And then we're going to await another signature right here. This one comes from the connected wallet, just like in the previous example. Once both the app and the user have signed, we can submit the transaction. And the UI component is very similar. Let's do one more thing to complete this exploration. On my screen, I have the PPBL 2024 transaction examples repo. And right here, this is the example of a token that I minted in the previous video. It had the currency symbol starting with 3223C. I'd like to be able to mint a token with the exact same policy ID in my front end. Here's how to do it. I noticed that the native script looks like this with a pub key hash like this one. This pub key hash was generated from this key pair right here. And if I open up this SKey file, once again, committing a cardinal sin of blockchain usage, showing this string to you on my screen is just like showing you my private mnemonics. I would never do it on mainnet. But for now, I can copy and paste this string right here into the component we were just looking at. Right here. This is what's meant by the payment string of type CLI. And once again, that's the private key. If I save this and I go back to the front end, demo number 2 will now be minting an asset with this policy ID. Look at it. 3223C55. This is exactly the one we see right here. Look at those. So this policy ID was generated with both Cardano CLI and with Mesh. I'm showing you how to do this in a very insecure way. But of course, if you're building an application for production, there are ways to keep this payment key a secret and to build the application in your imagination. I hope that in this video, I've given you some ideas for things to try, and I'm looking forward to continuing to explore with you.